It's quiet in here. I really wish we had like elevator music before the meeting started, so you don't feel like your audio is not working.
You have your phone. You have a microphone.
I did that in one of the web transport remote sessions during the pandemic, and people were very annoyed at me.
You gotta choose better songs.
I mean, is there a rating system for elevator music? Yeah, like the Benny Hill theme song. Yeah. No, but it's more fitting for working group business. We'll give folks a few more minutes and then we'll get started. Yeah, slow Benny Hill is probably a good summary for what we do. Yakety sax, I think, is the name of the song. Right. All right. I think we can get started. Welcome to the Web Transport Working Group, IETF 114. It's really nice to see so many of you in person, more than last time and way more than for 2 years when we, had the first session of this working group in the pandemic. Next slide, please, Bernard. So for everyone in person, as a reminder, we've been doing queue management using MeetEcho. So first off, just make sure to join MeetEcho to get yourself on the blue sheets. We're not doing paper blue sheets anymore. There's a QR code to simplify stuff. Otherwise, it's accessible from the IETF agenda page. The full MeetEcho allows you to have access to the chat and otherwise the MeetEcho Lite, which this QR code gives you the opportunity to join the queue and to join the blue sheets, but without the rest of the interface. It works better than the other one on phones, for example. All right, next slide, please. So here's a reminder on the buttons. Please stay muted unless you want us to hear your keyboard, and there's a hand icon for joining the queue. Yeah, if you're remote, having the video on when you're speaking is pretty nice, helps us understand you better, but it's not required. Yep, here are some links, especially if you're following along remotely. Next slide. The note well. So some of you may know this pretty well, but it's worth taking a minute to discuss this. What the IETF does is covered by our note well, and if you're here, it means you actually said you read it on the page, but everyone is used to clicking things without actually reading them, so let me take a minute. One of the parts of it is that anything you say at an IETF meeting or on the GitHub issues or on the mailing list is considered an IETF contribution, and that triggers the IETF policy on intellectual property, patents, and all that. So if you don't know what that is, you should take a look, because if you're aware of a patent, it means you have to disclose it. And that could become complicated if your lawyers at your company could be upset at you if you don't do it right. So just make sure you read all this. And next slide, please. The NoteWell also covers the IETF Code of Conduct and anti-harassment policy. I want to take a minute to underscore that. We've never had a problem in this working group. Everyone has always been working nicely. So let's just keep doing that, because everything's more fun when everyone's nice. And if you see anything that you think is not great, we have procedures in place for reporting it. Come talk to me or to the Ombuds team. We'll make sure it gets handled the best way we can. Next slide, please. So as a quick reminder, the IETF has a strict mask policy for all working group sessions. If you're attending in person, you have to wear a mask unless you are presenting or at the chair table, which is far away from everyone and currently speaking. Also note that masks need to be certified with these certifications or something equivalent, which means that most cloth masks and surgical masks actually don't qualify. Those don't really do a good job of preventing transmission of the latest variants. So just FYI, we have free KN95 masks at the front desks if you need one and you forgot yours. They're come in all sorts of cool colors too. And if you're talking at the microphone, you don't need to take your mask off. Just get close to the microphone. It works really well. Next slide, please. All right, here are some more links. We're going to need a Jabberscribe and a note taker. Can we have a volunteer for Jabberscribe? All right, thank you, Jake. Can we have a volunteer for note taker? The fun part. Now I get to awkwardly stare at people in the room and remotely. And we're not going to start the session until we have a volunteer, because notes are very important. It's best if I don't have to pick someone. I see everyone's intently staring at their keyboard. Thank you, Jake. That is amazing. All right, can someone do Jabberscribe? That's a very limited bit now. Thank you, Alan. All right, thank you both. Oh, yes, we are now using Zulip. So you can either join through the MeetEcho chat or through the Zulip client, and both of them seem to work and are bridged together. And if you want Alan to say something, because for example, let's say you're remote and you don't have audio, just say Mick : something, and Alan will jump in the mic queue and say what you said at the microphone. Awesome, thanks both of you. Next slide. This is our current agenda. So first is me blabbering around for way too long, then an update on the W3C process for Janivar, then discussions on capsules, and on the capsule design team for H2 and H3, led by Eric Kinnear, and then going through some issues for Webtrans for H3 from Victor, and then we'll wrap up. Does anyone want to bash this agenda? All right. Next slide, please. Janivar, are you? We see you.
Okay.
And we can't. Oh, say something again.
Hi, it's me. Can you hear me now?
Yes, we can. Go ahead.
All right, thank you. So I'm Janivar, co-chair with Will Law for the W3C specification for web transport. So I'm here to give you a progress update on changes since March 24th. So we published another working draft. The latest version is June 23rd of this year. And we have a charter extension underway for an additional year because the current charter expires September 22nd. So if you have input on that, it's still not too late to provide. And then the next bullet has a typo. It should say more realistic timetable for the year because we had an earlier we presented an earlier optimistic timetable that was not anywhere near realistic. So currently we're aiming for, this is what we're aiming for, end of September for candidate recommendation, which requires stability in API. And then by end of year, we're hoping for, that's our goalpost for proposed recommendation at the moment, which would require 2 independent implementations per our charter, which would put us in line for a call for review in February. And ideally, everything works, we have publication by recommendation by the next AC meeting in April-ish. All right, so we've defined some milestones. We have the original milestone for the initial implementation that shipped has 3 remaining issues. We've been a bit slow to close those, but none of them are major. We have a new milestone created, which aligns with the W3C release process of candidate recommendation, where we have 10 open issues, where about 6 are ready for PR. Next slide. And so here are some decisions since our last presentation in March. We have added per stream stats. That means per outgoing and ingoing and duplex stream, not datagrams. And these are bytes written, bytes sent, and bytes acknowledged, which are not total network byte counters. However, they're mostly concerned with the bytes, application bytes that are written to the stream, and how much of that has been sent and how much of that has been acknowledged. So bytes acknowledged will always be less or equal to bytes sent, which will always be less or equal to bytes written. And then for datagrams, we reduced the priority algorithm to normative guidance because we found some mistakes in it. We still haven't gotten any further on specifying that algorithm in detail, so that's left to implementations. We put some datagram stats in a subdirection of get stats, so we have a couple of additional datagram stats that are dropped too big, dropped incoming, and lost. And for the web transport constructor, we now support a require unreliable true Boolean, which defaults to false. This is so applications can in the future specify whether they want to require UDP, and by default they will get fallback to HTTP 2. And we added another read-only property for that so that you can tell what you're looking at. Another issue was, is connection pooling off the right default? And yes, so allow pooling still defaults to false. Next slide. All right, so current issues of debate. So we have 3. The remaining issues, we've been circling around the same remaining issues. And this is one of them, which is people want to send media. And that doesn't always work so great with the default congestion control in Quick. So we have agreement to provide some constructor level configuration API surface that would allow an application to specify its preference for the type of congestion control to be used. Now, we know that that's not necessarily available anywhere yet. However, we hope that we can get the API ready and have bashed out all the API decisions here to get us to candidate recommendation. And we can then subsequently mark this as a feature at risk if implementations fail to materialize prior to proposed recommendation. So discussions around shape remain. So we have 2 proposals with 2 directions, basically. One is highly abstract input that you specify basically the type of congestion control, the type of problem you want congestion control to solve, where the default would be throughput, which we have today, and then low latency would be a sort of application hint that I want to send something that is more real time than that, and with different trade-offs. And the alternative is to have basically a getter that exposes the names of available congestion control algorithms, and then you can then specify more specifically. You can learn what the browser has, but you can also specify a specific one. Next slide. A second issue is datagrams versus streams and relative prioritization, having a prioritization API. Discussion seems to center here on ordering instead of bandwidth allocation. That's an observation from the shares. Ordering requires strict and not weighted levels. The desire here seems to be to support use cases around one frame of media per stream, as well as a control channel, a high-level control channel that you can't starve, as well as real-time audio video streams and long-term background downloads. So some schemes may need as many levels as we have objects in flight. Current proposals boil down to, again, there's disagreement. So on one end, I think at a minimum, we think we need to expose at least 8 resettable levels to match what browsers are doing in most cases. And this would allow JavaScript to down prioritize ongoing streams by basically saying, on this stream that I've sent before, set its priority now to a lower level, which should give enough granularity to solve most problems with some effort. And the assumption there is that you are going to have JavaScript involved in the send loop, that it's going to be very active and responding to changing conditions in your connection. So this is the low-level version. Now, the alternative would be to provide something more upfront, where you can specify fixed levels, and that has been specifically requested for Warp, and Chrome has volunteered to investigate if that is practical. Having int32 number of levels would provide JavaScript with some more ability to just here are all the priorities levels I want, send it to that order, and I don't need to change it later. Next slide.
What's up, Jake?
Is there should I ask questions now, or I have a question about the
Yeah, but for next time,
Okay.
go in the queue from the button, but yeah, go ahead.
okay, sorry. Hi, I'm Jake Holland. I wanted to ask about the congestion control API. Are you also going to set the server side congestion control with this API?
No, I should have clarified. This would only be for we assume servers will take care of their own congestion control, and clients in that case will just receive what they receive. So apologies. So this would only be for ingestion, basically for clients sending media to servers. That's the missing gap that we're trying to specify. Thanks for that question.
Thanks. And just for everyone, I think it's really important to get some IETF involvement in these issues from the W3C. So I just pasted a link to the GitHub in the chat here. And I think the congestion control one is a perfect example. So there might be some people in the room who have opinions on if latency or throughput matters more. And there might be more in this room than there are at the W3C. So please go and comment on those issues. That's what we're asking for here, because that's the kind of thing where the W3C has to figure out an API for it, but we have the congestion control experience at IETF. So this is the kind of cross-pollination that we love to see. And I see Bernard in the queue.
Yeah, I just wanted to mention something, Jan, of our which has come up at this meeting, which is the idea, some of the I4S stuff. And in that situation, you can have algorithms that are really about both latency and throughput, like Prague. So anyway, just a weird little factoid.
Yes, there was a detail in the API I didn't show, which is that you can still, for the second proposal, when you expose the name, you can also expose other attributes of each congestion controller, such as what the aim of it is, and you can have enums for several of these properties, if you will. So, but thanks, David. That's a good question. It's good to highlight that these aren't set in stone in any way. This is just early discussion, and if they provoke you to participate, that is excellent. So we're definitely maybe a bit. We could definitely use some more input from more people, and that would probably help move this discussion along.
And I see Omar in the queue. By the way, if you get in line in the queue, don't hesitate to like walk up to the microphone as well, so you're ready to talk when we call on you.
Omer Shapiro, Apple. Can you hear me through the mask?
Speak a bit as close to the mic as you can, please.
Omer Shapiro, Apple. As David hinted, there are many people with opinions about what matters more, throughput or latency. We spent 4 wonderful days discussing this last year. The opinion that I'm going to voice is that it may be it may be not useful to allow the application to set the name of the congestion control, because by careful tweaking of the parameters, one can cause Neurino behave like Cubic and Cubic behave like Tahoe and what's not. It may be much more productive to have the application express its goal. Do I want to be, do I need real-time-ish latency? How sensitive am I to delays? How sensitive am I to throughput spikes, etc.? That's what I have to say.
Thank you, Omer. Can I ask you to like kind of take what you said and put it in that issue? I think that's really good feedback. I'll post a link to that specific issue in the chat. Thank you so much. Stuart?
Thank you. Yeah, I think that's good input. Thanks.
I saw David was talking about throughput and latency and looking meaningfully in my direction, so I felt compelled to say something. I worry here that there's a tendency to overcomplicate things. As we've seen this week at the hackathon with the enormous work done on L4S and other things that have been going on in the industry this year, it's possible to have low latency and high throughput at the same time. It's not an either or choice. Priorities become very problematic because somebody's got to decide what the relative priorities are. And if you have enough bandwidth for everything, then it doesn't matter. Every flow gets what it needs. And if you don't have enough bandwidth for what you need, then it becomes extremely tricky to figure out what is the right way to resolve that. Do you have a strict priority where you have total starvation for the lower priority things, or do you have some relative priority? This is all very complicated, but the good news is with L4S and similar technologies, the whole problem goes away. You open multiple streams, and they each get a nominal fair share of the capacity when it's scarce. When bandwidth is abundant, then everything gets what it needs. So I guess the summary is that let's not overcomplicate this with mechanism that is really hard to understand. And even the people at the IETF who are congestion control experts find this hard to understand. So the average web developer is probably just going to twiddle knobs randomly without even understanding the implications of what they're doing.
Thank you, Stuart. Can I ask the same thing and and also to everyone to also add that on the GitHub issue for the W3C? Thank you. Alex?
Hi, everyone. I'm Alex Chernowski. I work at Google. And one of the things I wanted to mention is that I was a little bit surprised when I saw this slide, because I remember when we were deploying BBR on the YouTube CDN, and one of the concerns that we had was that we actually saw people complaining about BBR's initial lack of fairness with all the other congestion controllers. And one of the things that I worry about here is that even if you do something nice, like saying, aim low latency versus aim throughput, if you give people the ability to choose these things, they might actually end up with pathological behavior on the broader internet, even though they've set their aims. And I think that my gut feeling is probably be better to focus on high quality congestion controllers, which do well most of the time, and not give APIs which might actually result in poor performance unless you are very careful and know how to hold them. I think the experts who work on congestion control know very well how to do this well, and the rest of us should benefit from their knowledge.
Thank you. Luke?
Hi, Luke from Twitch here. So first thing, the congestion control, it's something that is, I think the low latency hint is pretty important. One of the things with Warp that we struggle with is queue management and just trying to have this buffer in the socket that needs to be sent. And buffer bloat is an issue. Like if there's 500 milliseconds of RTT, it's like, there's no point prioritizing anything. Like you just, everything's gonna be ordered over the wire. So just a way of, saying congestion control, like keep the RTT down is important. And for the next slide, just I think there's two little things that come down to it. One is, like you said, mentioned, ordering is important. It's not clear if the 8 levels, the ordering is is priority 2 always lower than priority 3. And exactly like you mentioned as well, you need at least enough levels as there are active streams, and 8 is kind of low. But for Warp, it would be fine, honestly. But if you start doing stuff like per frame priorities, then 8 is just going to be artificially low. It's almost like a flow control limit of 8 hard-coded. There's just not much you can do. But end of the day, it all comes down to buffer management, just a way of saying we want this data to be sent over the wire first, and nothing else can get in front of it. Thank you.
Thank you. Jonathan?
Yeah, Jonathan Lennox. I mean, I get the impression that what is actually meant by throughput versus low latency is cubic versus GCC, which I mean, personally, I'd be fine with. But I mean, obviously, short term, longer term, presumably congestion control people will come up with something more clever. But in the short term, those are the two algorithms that are actually deployed in Chrome. And I suspect the idea is to switch out the one for the other.
Just to add, as someone who used to work on Chrome,
Yeah.
Chrome supports BBR as well.
Okay, well, but yeah, I mean, I think the goal of the people who want the low latency is to basically to get something like GCC, for the interactive media. GCC, Google Congestion Control. Okay. Oh, sorry.
Thanks. Yeah, to relay that conversation that happened away from the mic, you mentioned GCC is Google's congestion control, not everyone's second favorite compiler. Victor, you're next.
Victor? There you are.
Yeah. Oh, sure. I just wanted to say that.
Get closer to the mic, please.
Okay. I just wanted to say that there is practical trade-off between throughput and latency in the sense that there is some level of fundamental uncertainty of what your bandwidth is, and any attempt to probe it would result in building up the queue. So that is one of the fundamental tuning properties that pretty much every congestion control scheme has to overcome. So from that perspective, setting latency targets makes sense.
Thank you, Victor. Ian?
Ian Sweat, Google. Yeah, I would also prefer a objective-based approach, whether it's latency or throughput. I mean, even 2 levels is vastly preferable. So like there are times, or we actually have deployments where we're using BBR V1, but we have it tuned to be much lower latency. And it's not as good as like, a real-time congestion control, but it does prevent buffer bloat. And so for a given congestion controller, as stated before, you can commonly tune parameters to like provide output that's much more similar to one or the other. I don't really know what we're going to do with Cubic in this situation. Cubic seems like always the wrong option as a congestion controller, but it's becoming a proposed standard and it's what we got. So let's hope that no one actually ships Cubic by default here. But
thanks, Cullen.
Fascinating to hear. The only thing we're standardizing sucks. I wanted to actually jump back a bunch to, there were some comments about users of this at the API level will just be confused with this and not know how to set these things. And that's unquestionably true in some cases with all these things. I'm not arguing against that. But I think that is the wrong thing to design for that. The thing is, we have to realize that whatever levels of controls here we give limit what the applications that literally billions of users use, like Zoom, WebEx, these other things that are using huge numbers of minutes. they do know how to set this stuff. Okay, they have some very good people at all of those companies that are doing broad WebRTC products, and if you don't give them the controls to be able to set things up the way they need, whether it's Twitch or somebody else, they just can't use this, and they will just abandon the web stuff and go use thick apps, which was the problem. So we have to design for the use cases that represent large numbers of end users on the internet, not design for an average web developer who may not understand this stuff. So I think that we should design for giving lots of control of what's going on at this API level. And I think that's a different direction than we have traditionally gone on JavaScript level APIs, but I think it's necessary if we want this to be successful. Thanks.
Thank you. And I've cut the queue after Eric on this specific topic.
Cool. Tommy Pauly, Apple. So to Colin's point, I'm sympathetic that you want to be able to have fine-grained control, particularly like if you're doing something like option B, where you want to give like, here's the specific name of my congestion control algorithm. And I'm sure the people who know what they're doing will want to take advantage of that. My comment, though, on the other style, if we have something like A that's more like, I'm describing what I like. Is there a reason that, and maybe there's something else in the API already, but is there a reason that we're specifying the properties of the congestion controller we want, as opposed to specifying the properties of the traffic we're doing, to say, I am doing real-time latency sensitive interactive audio, or I'm doing just streaming of video, or I'm doing more bulk data transfer. And that way the system can choose the right congestion controller, but also potentially other things. And that's the model that we've seen in other APIs and like in taps and stuff. Like when they expose it, it's like, this is your category of traffic. And then you can make potentially other decisions rather than having the application try to describe the congestion controller that they want with these other names like low latency and throughput. So like, if we're not going to give it a specific name, can we describe the traffic instead of the congestion controller properties?
That makes sense. Thank you, Tommy. Mo?
Mo Zanatti, Cisco. Regarding Colin's point, I think if you look at the WebRTC example where we started off, thinking this stuff was way too complex for the average, JavaScript person, don't give them control lists. The browser has to do the RTP, the browser has to do the codecs, the browser has to do all of these things. And then we started unwrapping that, and now we give more control, and now you have web codecs, so you don't have to do RTP, and now you have WASM that can do the codec directly at JavaScript level. So I think we should realize that the application innovators are faster than the browser vendors, and we need to bias some of our designs to that. One specific thing on the prioritization, though, when you start talking about abstract levels, 1, 2, 3, 4, 5, 6, whatever, like someone said, those numbers don't mean much unless you know what the actual prioritization method is, whether it's, strict priority or what the queuing discipline is and all of that. One of the things people may want to consider is in RMCAT, there was a proposal called NADA. It's actually an RFC now, but it's an experimental congestion control. And one of the interesting things about it is it has weighted fairness. And so rather than expressing priority in terms of, abstract numbers, they are weights, and they are weights relative to what a default unprioritized stream would be. So you have an atom almost, as if you have an atom stream that if you don't do anything, that's what you get. But if you want to have a priority, you specify a weight. So if you want to be a three times heavy stream or a half heavy stream, so that weight is in terms of an absolute thing. It's in terms of, it's relative to an absolute thing, which is the default stream that you would get if you didn't do any prioritization. So I think that may be a useful concept to look at when you look at doing the prioritization APIs.
Thank you. That makes sense. Eric?
Eric Kinnear, Apple. If we go back to the congestion control stuff and continue to talk about it, one of the challenges that we've seen in trying to express something like low latency and throughput, and I'm usually one of the first people to jump up and say, no, describe what you want, the properties of what you're looking for, more than, hard coding cubic and assuming that's just going to get you what you want. But I think we've alluded a bit in this discussion to the fact that like you might have something that gives you both low latency and throughput. And so we've had real trouble trying to specify something that actually makes sense in real life for people. It's almost like you want the inverse of that, of let me tell you the thing I am most willing to compromise on. Because we haven't talked about like power here, but that's another consideration that you might be taking into account, especially if you're trying to upload something to do ingestion of media in the background while the user goes off and does something else. And so once you start saying, oh, well, I'm most willing to compromise on latency because I'm interested in everything else being better, that starts to get really messy and kind of gross. So I would almost support what Tommy was saying of either let's go all the way up to the top and like describe what we're doing rather than some intermediate property that we think will accomplish that goal, or, and maybe both also, give people a direct ability to just say, nope, like I'm advanced, I know what I'm doing, I'm working on developing congestion controls, and like I know I want BBRv2, let's do it. That's going to be exactly what I want.
Awesome. Thanks, Eric. All right. I had a feeling that just poking the congestion control bear would be very successful in an IETF meeting, and it was. So thanks everyone for the really good discussion. I'll repeat my point about please adding that on the W3C GitHub. This is really good input for them, and that's something that they can act on. So thank you. All right, Yanivar, keep going.
Yes, thank you. Can you hear me? So yes, thanks again. And yes, I think we should say the W3C will be probably perfectly happy to specify whatever you guys come up with, and we're very open to your input. So thank you. The last slide, the third issue under debate is to expose some stats to enable JavaScript to build more RTP-like real-time protocols for client to server audio video. So the previous discussion was all about giving JavaScript control knobs for what the browser can do about it. And there's some who are trying to hand off this wholesale to JavaScript as well. And somewhere in the middle, you want to control all of this. So this it's a separate issue that we were tracking. It's assumed to be about datagrams only, or at least at the connection level only. This is again open for discussion. Current datagram stats only detail loss through we have expired outgoing, dropped incoming, and lost outgoing. And so we've struggled with what kind of stats. So we've asked the question, what kind of stats would JavaScript need in order to build its own congestion control algorithm, for example, here. And so there's an RFC 8888 that suggested latest RTT, packet departure, packet arrival, which I assume is arrival on the server, right? And then ECN, maybe an ACK info would be sufficient. And we've also reached out to David Baldusin, I hope I got your name right, for some experimental data over implementing RTP over web transport with BBR2 or maybe BBR2 plus Scream. So this is still, we still need more information here to understand what stats would be needed. So if anyone else is doing experiments like this, we would be very interested in your input. And the reason why this is only for datagrams or only at the connection level is that the JavaScript API for outgoing and incoming streams do not operate at the packet level. So questions we still have are packets and datagrams sufficiently analogous for an RTP-like implementation? And this is again an exploratory issue. So questions welcome, or input welcome, I should say. I think that's my last slide.
All right, thank you, Janivar. Yanivar, sorry. Anyone have any questions on this before we move on to the next topic? All right, well, thank you very much. And now it's Eric's turn. Come on up and Take the mic off the stand, probably. And there's a pink X again.
It's almost as good as a box.
Hmm.
How's that going to do? Yes, no? Good, bad, sweet. All right. Cool. I'm Eric Kinnear from Apple, and if we can get the next slide, please. We're going to talk a bit about the capsule design team that we started in IETF 113. And the main question was, what the heck should we do about capsules? So like, should we use them? Should we not use them? We had an existing H2 spec for how we do web transport over H2, and we were defining all of these new H2 frames that we wanted to use to make a kind of baby quick that you run over an H2 stream. And we said some of these could also look very, very similar to what we're using in H3, where we defined a couple of different capsules as well. And if we go to the next slide, we can see like we had a datagram capsule, which is coming from HTTP datagrams. And we want to use that to send it on an H2 stream just as much as we want to send that in H3. There's also a closed web transport session capsule in H3. And if we go to the next slide, we can see we have a whole pile of them for H2. So the obvious crossover here is something like datagram. We also had padding, reset stream, stop sending, actual stream capsules, and then flow control, which we've stuck onto one line here, but is some combination of max data, max streams, max stream data, and then blocked variants for all of those things. This is our new compact representation of that. All right, next slide, please. We had looked at this slide in 113 as kind of the precursor to spinning up this conversation. So I wanted to just look at it again. So this is the full list of all the different things that we defined for H2. And if you go to the next slide, we had kind of tentatively talked about, hey, there's this datagram one and it's shared with H3. And so that would be cool if these things shared and we didn't just define two of the same thing. And that's kind of what got us talking about, should we be sharing everything else? How does the rest of this work? What is the role? Can I send a WT stream capsule on an H3 stream? And is that cool? Does that give us awesome version independence? Does that destroy everything and make things go down in flames? So next slide, please. We also opened the can of worms that is flow control. That's what we started with in terms of problems for everything. And like I said on the slide here, we'll talk a little bit more about flow control and some of that stuff later. But the opportunity arose to say, hey, we have all of these different like max stream data blocked capsules. Should we send that on H3? And what does that mean? So that's kind of what we set out to solve. Where we are right now is we have a pull request against H2 and a pull request against H3 that we will send the links out to on the mailing list and ask for a bunch of input and review. I'm going to summarize very quickly in slide form what those do, because that's often a lot more grokkable than reading a bunch of diff from what it used to look like. So if we go to the next slide, the first thing that we talked about and came to a proposal on was, what do we do with this splitting a datagram out into a native H3 datagram that is actually truly unreliable and quick, whereas obviously when you're sending a datagram over H2, it's going to get retransmitted whether you like it or not. And so we've been referring to that kind of as you're exploding something out into a native feature, or 6 other terms for it, but I chose to use explode here, so we're going to continue with that one. And we looked at some pros of why we would want that. It's really attractive from a symmetry perspective to have this single conceptual model that looks kind of like a miniature version of Quick that you can run on any HTTP exchange that you have anywhere. You could potentially get H1 support out of this for free. You just, doesn't matter. It's completely transport agnostic. This is just how I send web transport streams. There's a web transport stream capsule, and it just goes where it's going to go, and it gets there how it's going to get there. This is also kind of fun because if we reuse all this stuff, things that we do in the future for different extensions, if we add new capsules, those automatically work for H3, they automatically work for H2. And if there's a but coming, it's on the next slide. There's a way longer list of cons, which are mainly and primarily that we care the most about H3 for web transport. And H3 is the one where you have the most native feature usage already, right? So like datagrams actually go in H3 datagrams. now you'd have to be able to handle all of those capsules arriving on the same stream. So when you had different web transport streams, instead of those being different H3 streams, you'd have to cope with multiplexing them onto a single H3 stream. And as much as that's great and gives you all this great protocol, kind of transport independence, now the common case, you have to be like, how's it coming in? What do I do? Are you allowed to switch partway through? Like, what if some go over a single H3 stream, but others you choose to split out into its own H3 stream? And like, can I restrict that if I'm not willing to give you some of those resources? And what does that do to our stream limits for flow control, which we're going to talk about in a second? So that's kind of painful. There's also one of our only 2 capsules so far for H3, which is closing the web transport session. Doesn't really make sense with the like, how would you explode that into a native feature? That's not a native feature. That's just a signaling about the H3 session. And then similarly, one of our other main pros that we were excited about doing this with, which was that, if we define it all in one place, when you improve it, everybody gets those improvements for free, and we don't have to keep having a parallel document for every possible version we want to send this on. Gets more complicated because if we decide that down the line, some extension needs us to have used the native feature or needs us to not have, we're kind of screwed. So the proposal here is that you have a per capsule requirement for how to send it, which is kind of already inherent in capsules and is already a thing. But essentially that we're going to require that anything that can be sent as a native feature is always sent as a native feature. So you are not sending a datagram capsule on your H3 stream. It is an actual datagram. And that persists throughout all of H3. Everything that H3 can split out, which is most everything, looks just like it does today. There's no debate over, oh, but it came in this other way. Am I supposed to handle it some weird different way? And can I signal to the other person about it? So no weirdness there. Just if it can use a native feature, it must use the native feature. If you're in H2 and the native feature isn't available, then it is sent as a capsule on the existing H2 stream. Next slide, please. This is a nice, easy one. Capsule protocol is a header field. In the HTTP datagram document, we cheerfully say that you can either use the capsule protocol header field, or you can simply say that this upgrade token implies that capsule support exists. And we're going to say, great, the upgrade token web transport means capsules are a thing and you have to be okay with that. Mike.
Does that also require that the underlying quick connection must support datagrams?
Ooh, that's a good question.
Because you've made an assumption there that it must be used, but you can't assume that's true for all H3 unless you're making requirements on the transport stack underneath you.
That is a good point. We require capsule support, and we say that if you have, that's an interesting one. If you have datagrams available, you have to use them, but you have a button, push the button.
No, join the queue and walk up to the mic, Victor. You know how this works.
I was going to ask that question in the previous slide, but it took me that long to find the button again.
I'm right there with you. How do we normally signal if datagrams aren't there? Because we just say, like, I support datagrams, I'm good to go. So I guess if they don't do that, then are you actually doing web transport?
Right. So Tommy Pauly, the datagram support is indicated via transport parameter in Quick, so you need that, and that might not be there.
Right.
And you have the H3 level setting. So, either you're going to say you don't, like, web transport is just going to break in those cases, or you need to tweak the language where you say that you must use datagram in H3 to say you must use datagram if you have the transport parameter, but if for some reason the other side didn't do the transport parameter, you know already that it can't do it, so then you must use the capsule version of it. But I think saying that you have to support capsules is fine, because you always can do that.
Well, we say that if I can jump in, we say that web transport uses the capsule protocol. So therefore, if you support web transport, you support capsules. That's a given. Yeah.
That one I think is straightforward. The only question is, if our main goal here was to not force you to write code that could handle them coming in both places, Are we willing to say, if you don't see both quick datagrams and HTTP datagrams present, that you're just going to take your toys and go home and no web transport for you?
Yeah, so we've talked about this in the past, and I think the same set of concerns apply here. You can very much on a sort of connection by connection basis have a stack of things that need to be prerequisites for the next one. So you need quick in order to get datagrams, you need datagrams in order to get H3 datagrams, and you need H3 datagrams in order to get web transport to work, is a reasonable thing if we think about it on a per connection basis. And I think that's still okay in this context. It does mean that if someone's going to try to deploy this and they're using intermediaries in their deployment, they're going to need to ensure that when the front end receives one of these things and says, yes, it's okay, the connection onward is dealt with somehow, whether that means translation or whether it means full-on support for the same sort of feature set. I think that's just something we can write down and explain. I know that's going to make some people unhappy, but those people were probably unhappy with the set of design choices we've made here anyway. So I think this is fine. I do kind of want to caution that when you have something like the upgrade token that sits on the top of a stack of prerequisites, I don't think you want to just say, oh, because the upgrade token is there, you can not provide the indicators for all of the prerequisites. I think you want to have all the prerequisites also signaled in that process. And if they don't appear, then something's broken and you fail. So that you can build software that's rational with all of these things. So you don't have to, okay, so I've got a layer that's dealing with capsules. I don't want to have that layer suddenly need to be taught about web transport upgrade tokens just so that it continues to function. So this is fine.
I would note that we broke that principle in one place, I think, for Extended Connect.
Victor did that.
Yes, indeed. It was an encompassing we.
Yeah. I understand that to be a problem for some people, but I think this whole idea of implicit signaling that's tied to other things is problematic when it crosses layers. It may be appropriate at the layer in which it was done for that one because it was all tied into the same negotiation. I don't like that, but that's where we ended up, and
yeah,
I guess I'm in the weeds.
To jump in on that specific one, there's an issue open for that Victor will be discussing later.
Okay, good.
Yeah.
Martin? No, not Martin, Martin.
I would like to point out that there is a use case of web transport that doesn't require datagrams. It's a somewhat primitive use case, but you can imagine just doing the stuff you did on WebSocket via web transport now and benefit from streams and never send a single datagram. So I don't see why datagram support needs to be a requirement.
That was going to be my next question. Is there anybody who's planning on deploying this that doesn't have datagrams and doesn't want them and would rather have code that handles datagram capsules coming in on an H3 stream? Because that's kind of your alternative, right? So you're still going to have to write code that has the letters data and gram in them. It's just now you have to have an if statement and deal with it in multiple places.
Or do I not? Like, there's no requirement that I ever send or receive a datagram, right? I could just say like, this feature is not available as we have in HTTP.
Completely fair.
Martin?
I noticed the queue's just gotten long. So I think what we're looking for here is interoperability. And if we have people that want to use the protocol with a sort of, I'd like to pick and choose the pieces that I'd like, we end up in a situation where we don't have interoperability in those cases. If you have a deployment that wants to use something that looks a little bit like web transport but doesn't have datagrams in it, that is possible as a proprietary protocol, but building something that doesn't have datagrams in it and specifically designing to allow for that possibility does complicate how we build this thing. And I think it's a complication that we don't necessarily want here. implementing datagrams or implementing the possibility of receiving datagrams from someone is relatively simple to do. And even if you don't plan to use them and all you do is throw them away, then that's probably something that you could possibly do in that context. And then you would get interoperability. However, building something that says, well, datagrams are optional makes it very much more difficult for those of us who are building to this sort of thing and have to talk to arbitrary servers. And then we have to deal with the possibility that maybe datagrams aren't present, and we have to think about how to move things on capsules and all sorts of other things. So I think that's nice, but I don't want to go there.
I would tend to argue that, aborting when you see a datagram is about as hard as dropping the datagram and just pretending you never saw it. But yeah.
Yeah. David Skenazy, no hats. Well, mask enthusiast hat. So just to add, in the HTTP datagrams document, we say that you must support receiving datagrams inside capsules. So that's kind of a requirement here. I mean, at the end of the day, if you already have a capsule parser, which you need because of the closed web transport session capsule, having that call the I received a datagram frame function is pretty trivial. So I wouldn't worry about that too much. I think this boils down to, do we want to say you must send them over datagrams if they're available, or you must support datagrams? At the end of the day, I cannot imagine anyone deploying web transport without datagrams, all quick stacks that are in the space. It is the easiest thing to add to a quick stack by far. So I don't think we should spend too much time on this. And now with my chair hat, I'm gonna lock the queue on this one after Luke.
Hi, it's Luke. So I've deployed a quick stack without datagram support. You're right, it's really easy, and it's kind of trivial to just throw them away. I think the only concern is maybe capabilities on the W3C side. I think there was a slide there saying datagrams are reliable or unreliable, and it's kind of hard to tell if a server actually supports these unreliable datagrams if it just lies. It just says, I support them, I need to say this to get web transport, but then you actually try to send them and it doesn't work. So there might still be a use case there to say that the, yeah, I don't know. I can't really think of any reason why you can't just lie about it, but I definitely would like to avoid having to implement anything complicated with datagrams. There's just no reason to use them in most use cases, I think.
So to summarize our options, which I think David said very nicely, we kind of have the choice of saying either you can optionally have datagrams and everybody has to be able to cope with them showing up in multiple ways in multiple places in different forms, or we say you don't get web transport if you don't have datagrams, and it's easier to implement datagrams and throw them on the floor than it is to consider both. And I think that second one is the thing that we're proposing right now, but that would be a great thing to chime in with on the actual pull request for this stuff. Or we can also make an issue if we want to have a continued back and forth. But like if you have a implementation where it really would be a burden, it would be good to talk that through. All right, capsule protocol stuff is nice and easy. That's why I said this was a nice, easy, low drama slide. Next one, please. Let's talk about flow control. This is not low drama. The first one is fairly easy. So we've talked about having a setting to limit the number of sessions that you can have. And if we go to the next slide, this ends up being fairly ergonomic. It's pretty straightforward. We say instead of sending a flag that says settings enable web transport, you just send settings web transport max sessions. And if you set it to 0, no web transport for you today. But if you set it to 1, you have web transport, you have no pooling, you get 1 session. And if you set it to more than 1, now you have however many you asked for. So completely reasonable. Sweet, next slide, please. So we've talked about that part. The next piece of flow control that adds some complexity is limiting the number of streams within a session with max streams. So kind of the problem here is, especially in H3, where you have stream limits for flow control. But if you have multiple web transport sessions and each of those are using native H3 streams, it would be very, very easy for my first session to use the entire budget. And my next session says, I'd like to open a new web transport stream. And the answer is, haha, nice try. So this is a way for within a web transport session that in a context that understands that, as opposed to H3, which just sees lots and lots of very equal streams. You can just say max streams and use that same capsule the same way we do in H2. And it's all fairly straightforward. And you just say, yep, this web transport session gets 10 streams and this one gets 100. And now I'm happy and I can limit things. And I see motions as if we're going towards a queue.
Just go ahead. So in H2, you have an ordering guarantee between streams. In H2, you have an ordering guarantee between streams. In H3, you don't. How do we deal with that?
Yes. So there's a fun caveat, which is that if essentially, I think to paraphrase, in H3, because things can come in out of order, if you've potentially closed a stream before the stream is considered to be opened, you lose that, you essentially leak that credit. And our answer is essentially, don't do that, and we don't think it actually is going to kill anything. There's more on a slide in that in a second. Can we go to the next slide? Look at that. Oh, we got some formatting fun here. So yes, so streams that are closed before they're opened are an issue. You essentially lose one from that session each time that happens. And the reason for that is because you can't necessarily tell that that was associated with that session because the stream is gone and you're not going to, when the frames arrive, you're having a bad day. And so I think we discussed wordsmithing some text around how the capsule kind of has to be paired to try to make that less possible, but I don't know that we ever got it to a 0% chance possibility.
I have a silly question. How does the session level max streams interact with the connection level max streams?
Connection on the H3 connection?
Yes, because I'm wondering is like, do you have to have a guarantee that like all of the sessions sums max streams must be less than or equal to the connection level one, or is it possible in a valid deployment to have the sum exceed and like have a higher limit? And like, does that mean that a particular session does not have the guarantee that it can get all of its allowable maximum max streams?
The latter. So it's very similar to what happens for connection level data limit versus stream level data limit. Is if you wanted to say, hey, I'm willing to give anybody 10 streams, I could say, I'm only allowing the whole connection to have 10 more streams, but any of you could take those 10. Or I could say, no, the first some of you only get 5. Fine.
Two things. So I don't understand the streams that are closed before being opened, because the stream internally has ordering control, has byte ordering. So if the fin bit arrives before the actual stream data, the quick stack will deal with that. The problem I see is that there's a race condition here. Like, let's say you give me 10 streams. I have the 10 streams open. I close 5 of them and open 5 new streams. And now the fin bits for the closed streams get reordered. Then you will think that I opened 15 streams and you will give me a protocol violation, I would assume.
Got it. The closing before being opened is essentially like, so if a stream gets reset before you knew it existed. So if I say, hey, I'm resetting the stream, and you go, excuse me, what stream? Very often, in at least several implementations, you basically say, okay, cool, this stream is dead. And when things then show up for it later, you basically just completely discard everything to do with it, which without careful wording, it means that you're also discarding the information that told you which web transport session you should have billed for that stream.
Alan from Dell Meta. So yeah, I think what Martin said about the streams that are closed gracefully with a fin bit don't have this problem, but the ones that reset could. And I think there may be a separate issue that we'll talk about in the H3 section, but I think the leaking it is bad and that we probably need a reset capsule, which would be reliable to make sure that that doesn't happen. So you would, in H3, you would reset the stream and also send the application level message, which is sort of like the way things work in QPAC.
And that would go on the control stream.
That would go on, that would go on the H3 stream.
So you'd basically say, hey, you needed to bill me for this, is essentially what you'd be saying.
Speak in the mic, please.
So I'm not even sure that we need this capability, honestly. There is always the possibility that you can have the bad session completely overwhelm the capacity of the connection. For instance, if I, as a bad website, or just one that didn't know what they were doing, were to create multiple web transport sessions and use lots and lots of streams on them, it's possible that you could exceed the available streams that are there for that connection. Maybe you forgot to close them, right? And it could be very simple like that. But that's the sort of thing that we'll have to deal with anyway, because the number of streams within a session times the number of sessions could well exceed the number of streams the entire connection could have anyway, at which point you have a connection that is entirely consumed by all of the web transport stuff, and you have no means of doing other things on that connection, like making a simple HTTP request, for instance, or making a new session or what have you. So I think that possibility exists anyway, and maybe just throwing this in the, well, we can do this later bucket is entirely plausible here. I'm not sure.
Well, and there is a line to be drawn there. So sneak peek, the next slide is going to be taking all of the data limits and throwing them in the, we'll deal with this later if we decide we actually need it and it's a real problem bucket. So we could choose to do that for this. The thing you say about, hey, I want to send non-web transport requests on this H3 connection. If you don't have some way to limit this here, you essentially cannot guarantee that that will ever be possible, right? Because the web transport session can just, whether you have one session or 10, can walk right up to the limit of how many streams you can have on your H3 connection and you're done.
So it's always going to be the case that you can exceed it unless you have reserved a few streams for the purposes of making other requests, which a browser is quite capable of doing if that's what we want to do.
So
but a lot of that's going to depend on what the server is willing to allow for. So if the server only gives us a budget of 3 streams, then we don't have a lot of options available to us. So some of this is going to come down to just having sensible practices on servers. And conveniently, the people who are writing the code to consume the streams also have some degree of control over how the server is going to be operating here. So I don't think this is going to be as much of a problem as we're making out. We're not in so much of an adversarial situation as much as we are in a situation of what do we do on the browser side to manage the resources so that it is easier for those people writing the server applications to avoid harming themselves, essentially. So it may just be that doing nothing and is still a viable option here.
Victor, and then let's go on to our next slide where we propose doing exactly that.
Yeah, one observation I wanted to make is partially that because some of this is limiting, so the situation is like when the client opens too many streams, so the browser can send a HTTP request. Well, browser can control the number of open streams on top of what's imposed by HTTP connections. That is to say, the browser might decide that you only get 32 streams on this connection, and there is no need to support this in protocol because it's all lawful to the browser.
The reason you would need to support that in the protocol is if you needed to have them explicitly communicate about it, and especially if you wanted to let the application have input into that, whether or not that's happening.
I'm pointing out that some of those resource problems are not necessarily the server imposing resources and limits on client, but are purely client concern and could be dealt locally.
Alan Frindell, I think the concern that I have with letting the browsers just decide like we're going to reserve some streams and it doesn't need to be communicated is that then servers have to deal with browsers that have different limits, or maybe you decide that you're not going to have the limits, or some browsers do or don't. So it's sort of inconvenient. It's better to be able to like have some guarantees. But I think also to Victor's point, I seem to remember maybe something like this along with WebSockets, where Chrome has some limit for like how many WebSocket streams you can have in an H2 session, which is kind of similar. So I don't know, it would, having some explicit way to communicate what the limits are, I think would be good.
Right. If I'm offering a server and there's 3 different browsers and they each reserve a different number of streams for extra requests, and my application needed 6 and half of them reserved 5 and half of them reserved 10, I'm now awkwardly screwed. Martin.
Going back in time 5 years, Google Quick had a configuration option for maximum concurrent streams. Seems like we have the exact same situation here. In Quick, we solved this by having stream IDs and allowing a maximum stream ID instead of a number of streams.
Mm-hmm. I like that. Next slide, please. All right, this is the part where we declare bankruptcy for bytes. And we say, if the conversation we just had seems kind of twisted and a little bit complicated, when you start having the same type of conversation, but for byte limits, it gets way worse. So we're going to say that at least for those bytes, you have the ability for any H3 stream, and obviously a lot of this also applies to H2, but specifically for H3, for any H3 stream, you already have flow control. You already can use it. You already screw it up sometimes. Let's not make it any more complicated. You can reserve practically pretty much what you would actually need. And so if we discover a need for some additional signaling beyond what you can already do in H3, across connection and then stream limits, and to the point of can the sum of the stream limits be larger than the connection? Like absolutely yes, and that can lead to all sorts of interesting strategies. We're not going to add any additional complexity there. If we end up needing some kind of thing that we'd actually want to signal about that, we can certainly add it later. It's not super hard to add capsules and extend things by making that work, but we're going to propose not doing that. So the number of streams we said was, this is a thing that you cannot necessarily do otherwise. And it'd be interesting if we can chime in with some clear text on how we would explain that browsers should do a sensible default there, or do concurrent stream count, or pick some other strategy. That would be excellent. But we said it was worth biting off a little bit of this complexity for streams, because that's something that you don't necessarily have good control over otherwise. But for bytes, you have lots of knobs. We have yet to prove that we can use those knobs successfully in every case. So let's do that first, and then we'll add more knobs later. Excellent. Next slide, please. Intermediaries make the entire conversation we just had a lot more complicated. That is also potentially a reason to have a little bit more explicit signaling if we needed to traverse some of that. So this is a place where we have a split between a way to conceptualize what's going on and the thing you actually need to do when you write your code. So conceptually, the proposal here is that, and it's less of a proposal and more of a reality, flow control is terminated at an intermediary. So when I have my H3 connection that is terminated by somebody who's then going to talk upstream of that via H3 or H2, a lot of those flow control limits are actually terminated, especially if they're translating between H3 and H2. But even if they're just sending H3 to H3 or H2 to H2, that intermediary could choose to allow someone to send it more than it's allowed to send upstream, and vice versa. So if it's willing to pay the cost to put the memory into buffering a bunch of that stuff and potentially having a sad day, you're perfectly allowed to have a sad day. But in practice, you can usually just forward the limits onward. So if we go to our butchered next diagram.
Yeah, my apologies to Eric and everyone for resizing the slides right before the meeting and kind of nuking some of the diagrams in the process.
So these lovely fast forward symbols that you see are actually double-ended arrows between these different boxes. And if we skip to the next slide, since I think building this in segments is not necessarily going to help much, we got more numbers here. That refers to a thing that's on the left somewhere. Conceptually, what this is saying is that if you're an intermediary and somebody's saying, hey, you can send me 100 bytes, you probably want to be very careful before you tell the person sending you stuff that they can send you more than that 100 bytes, which should be pretty straightforward. So you just join the queue. Yeah, let's do it.
How does that work? Because the client establishes the connection to the intermediary first, and during the quick handshake, you communicate these limits.
The initial limits, yes.
Yes.
Right. So you need some sensible set of initial limits, but essentially as you're going to increase those limits, you need to be careful. But yes, you could be stuck in a situation where when you establish your upstream connection, it says my initial limit is 50 and you'd already advertised 100, and you're going to have to deal with that.
So let's try to be a little bit more pragmatic about this sort of thing. This is going to be a gateway sitting in front of a bunch of servers. Yeah. And in a lot of cases, the gateway is going to know something about those servers. Now, whether that's based on the fact that it's already talked to those servers in the past, or because they're actually operated by the same people and they run off the same configuration is largely immaterial. The intermediary can advertise initial flow control windows that match those of the servers behind them. That's, I think, relatively straightforward. If there are multiple servers in the back end, they might do things like take the minimum of the servers if they have different configurations. And then as the backend server provides per stream flow control credits, the intermediary can just forward those credits onwards. And then you have essentially an end-to-end flow control, and the intermediary is in an interesting position there. I was just thinking there's interesting complications here when you talk about having quick on both sides of the intermediary, and when you have quick and TCP on different sides. With quick, if you get an out of order piece of stream information, you can just forward it on and sort of say, oh, this is just stuff that you'll need to deal with in the future. That's easy. With TCP, with header line blocking, you have to wait for everything and you have to buffer things up. So ultimately, the intermediary can't sort of blindly forward those things on in the TCP context, because it does need to have all of the space that it advertises available for buffering. Otherwise, it could end up in a situation where it has data that it said it could take, but it couldn't.
Right.
So, yeah.
And I think that's a really good point and kind of underscores the idea that conceptually you are terminating that flow control. You are responsible for whatever you choose to advertise. And the fact that in many cases it is fairly straightforward to send that through is okay, but the underlying reality, you can't just completely ignore that.
Hi, Luke from Twitch. So flow control is usually based on like I have limited RAM. I think the assumption here of the intermediary is like we've just got big beefy servers and they can have as much RAM as the client of the server. But I mean, exactly, like it sounds like it's a poor decision to just forward flow control if you're running a Raspberry Pi or something. Like there's going to be congestion. All of a sudden you advertised, a gigabyte of RAM available, but you didn't have that. So I'm not sure it's actually a good idea to ever forward flow control. And I don't think it's an end-to-end thing. I think it's literally just, I just have this much RAM available at each hop.
Yes, well, and Martin had also made a good point around if you're translating between H3 and H2, like H2 to H2 is pretty straightforward. H3 to H3 is pretty straightforward, plus some extra ordering fun. But at the end of the day, we're not defining a new signaling mechanism for this in the spec. So if you've got a bunch of big beefy servers, that's awesome. Other people may not have a bunch of big beefy servers. That's cool too. I think what we're trying to do is provide enough guidance that we're giving a heads up as to some of the pitfalls and the things you need to be careful with as you choose to do this. But what your intermediary chooses to do with web transport is not something like, we're not defining additional signaling about it. And we're not really putting any requirements on it either. So if you've got a Raspberry Pi and you want to be super careful and you want to manage it completely on your own and not have any signal from upstream like go downstream, that's totally cool.
Yeah, I think it's just sometimes with max streams it's conflated. Like it sounds like we want max streams to kind of be end to end, like it's meant to be an application level decision, but for data it's definitely not. I think is kind of my point.
Got it. Yeah. Thank you. Yeah.
Ian Sweat, Google. I would agree that thinking about this as end to end is probably just not going to work. But the good part is that like intermediaries that terminate like H2 and H3 already deal with this problem, and so like I'm not really sure you really need to say anything at all. I will call out one note from your example. The intermediary to the server could have like an incredibly small RTT, like on the order of a millisecond or less. It is not uncommon the client would have an RTT that is like 2 orders of magnitude larger. As a result, the BDP between the client and the intermediary is fairly often going to be probably at least an order of magnitude larger than the server to the intermediary. So unless you're going to give a bunch of information to the server about the client and that BDP, even trying to do end-to-end is going to hose you because like you're going to be sending far too little flow control from server to intermediary. So like there's a drag in there. Maybe it's even worth calling out like this isn't end-to-end. You're probably going to get yourself in trouble.
I think that is why the fundamental underlying reality is it is not end to end. It terminates at each intermediary. It's essentially hop by hop, as it were. And like what you've committed to, you've committed to. And you might choose, because you know that there's going to be way higher BDP, like you might choose to advertise something that's way higher. And if everything goes wrong, and even though you have a super low latency link between you and your upstream, like if that gets blocked for whatever reason, like, yeah, now you have to hold up, like you are left holding the bag, but in practice, like that's fine.
So what I'm getting from this conversation is that building an intermediary could be hard, but people do it anyway and have done so successfully for some amount of time. And it might be the case that trying to find the guidance that you're looking to put in here is subtle and difficult enough that maybe we shouldn't even bother. Maybe we should simply say intermediaries exist and that's it. Like something very, very simple and anodyne, basically. I don't think there's much here that we benefit from trying to explore all the various ways in which you might implement an intermediary under the varying conditions that Ian was talking about, because yeah, that's why people building intermediaries still continue to have job security, I think.
So the just for clarity, the current proposal is we're saying this is essentially hop by hop. If you commit to it, like you're the one left holding that bag, that's up to you. And any other text we choose to put on top, of which we have proposed very little right now. If we want to describe something that helps people and lays out some of the, here are common pitfalls and things you might want to think about, that's totally cool. But the in terms of our like actual pull request for this stuff, the only hardline statement that we're making is this is not an end-to-end concept. Like if you advertise something that's higher than what your upstream can do, like you got to deal with that. That's on you.
Colin James, I mean, anytime I was just sort of reacting a little bit to Martin's, you know, like anytime we're trying to wish intermediaries away, we 10 years later deeply regret having done that, right? But I think your statement that you have, what I read in the draft of, you're not wishing them away at all. You're saying very hardcore, you know, you have to fully be, you know, whatever you advertise, you have to provide. And that means you're a full SBC in the SIP sense, or a full, you know, I think that's a great way to deal. In fact, I think it's the only practical way to deal with intermediate problems. But I think you should claim you are dealing with intermediaries and this is the answer, not we're sort of, you figure it out yourself, right. Because the figure it out yourself, it leads to bad results later. Thanks.
Beautiful. All right, next slide, please. All right, so if we summarize what we've talked about, we are proposing that H2 should use capsules. We are saying that H3 should use capsules and share with H2 where appropriate, which is actually a reasonably small list. Our main reason for using capsules is because the frames look exactly the same, but now they're in a shared list and we can reuse them between protocols. We're saying that capsules will always use native features if possible. And I think we may want to split out a specific GitHub issue, even just so we can write down some of our conversation around what happens if datagrams aren't there, and how we are going to maybe have text that takes a strong stance on that, if that's what we want to do.
Eric, can you take the action item of filing that issue?
Yep.
Thank you.
H3 and H2 are getting a setting for max sessions, which replaces the enable web transport setting. So instead of it being 0 or 1, you can now have 0, 1, or more than 1. And the last one is we're proposing that H3 gets a stream count limit within a session, but I will actually split out a similar issue for that, where we can make sure that we've fully written down everything we need to for that stuff. And if we get to the end of that issue and we say, you know what, flow control is not the thing we were trying to solve when we talked about capsules, that is totally okay. Nobody will be sad with less of that. All right, so just process-wise, we have 2 pull requests for this. They're gonna move around a bit in GitHub and stuff, so I will send them out with links to the list. So keep an eye out for that, and if you can come in and read a lot of that, and especially if your reading of them does not give you the same impression as the words that we all just said, that'd be really cool to call out. But yeah, please give them a look. The diff for H3 is quite small. The diff for H2 is quite large. It's almost all packet formats and fun figures and stuff like that. So it's not super onerous to take a look at. So I will send a link out to that, and thank you.
All right, thank you very much, Eric. Any last questions for Eric before we move on? Okay, so process-wise, Eric will send out this email, and then the chairs will turn that into a formal consensus call on those PRs, since this is a non-trivial change to how H2 works. And then we'll, assuming that goes through, we'll have a set design going forward. All right, Victor.
Hello everyone, I'm Victor, editor for the H3 spec. H3 spec is hopefully approaching the state where it's almost done. So today we're going to go over some of the remaining issues. Next slide. So updates since last meeting. First of all, for the overview draft, we've merged the PRs that defines the common operations that any web transport should provide. This is meant to be as a layer of abstraction on top of web transport over H3, web transport over H2, and whatever else. This is mostly useful for people who edit W3C spec, but everyone is encouraged to read the updated version. Next slide. For web transport over H3's updates has been mostly minor. Notable one is since last meeting, as we decided, we clarified what happens when the go-away frame is sent on the H3 connection. And added some missing details about how exactly you turn down the web transport session. So on the next slide, we have about 10 remaining issues. Roughly 5 of those are either editorial or just need a PR. So the issues we're still not discussing are H3 is so we currently do not define what we do with HTTP redirects. The RFC 9205 says that we have to provide explicit guidance on what to do with this. Our current behavior in the web browser is that we explicitly do not handle them, as in there is no automatic redirect support. But we need some normative text in the draft. So do people have opinions on what should be there? David.
So speaking as an individual contributor, I would say just must follow redirects. It's not a hard thing to implement for browsers, and some folks could find this useful.
As an individual, an implementer, I err on should not. We've definitely, from what I understand, have ran in a bunch of implementation issues when with redirects in WebSockets, and there are some rough edges around the fact that those aren't really HTTP requests. And what does it mean? What is the difference between a redirect and I would moderately prefer should not, as in you could follow, but we will not normally follow. And
So question for the room as chair here, like either do browser implementers have thought on how hard this or annoying or risky this is to implement, or do users of web transport have thoughts on whether they would want this feature or they don't care?
So this advice that we've got is not actually very helpful advice, I'm afraid. And so when you think about using something like fetch, you would normally expect to have the redirects followed until the point that you get something that requires action on the part of the thing following the redirects. Here, I think, because browsers work following redirects generally, I would hope that we can follow redirects here as well, mainly because that's just how everything else works, but also because there is value in having redirects in terms of being able to put resources on different servers for deployment reasons, or being able to move things around when people are given a URL for something and they find that needs to move somewhere else. So I would be on the must end. Anything in the should may space here is awful because it means that you have no determinism. You don't know who's following and who's not. If we can find a set of reasons why you might not follow a redirect, that would be interesting. But I would probably err toward the must end on this one.
Mike Bishop, speaking from an HTTP perspective, I'm not entirely clear what it means to follow a redirect on a connect request to begin with.
Well, if you get a 3xx response code.
Yeah, I mean, I know how mechanically you would do it. You get the 3xx response, you go to a different URL, you reissue your connect request, I guess. But like it makes more sense if I'm trying to fetch a resource, if I'm asking you to perform an action, if I'm trying to talk to you, connect and getting a redirect back seems a little weird semantically.
yeah, there is a similar question, like, do you cache connect redirects? How does that work?
Hi, Luke here. So just like Martin said, it should be a must or must not. As a user, if I'm going to use a redirect feature on my server, I need to know if the browser is going to do it. Otherwise, I could just do it through some other mechanism. So if it does support redirects, that's one more tool to my toolbox. If it doesn't, I can just do redirects via like some other endpoint. So I think either way, just one of the musts.
I was getting Cullen Jenkins. I was getting up to say what Luke said. It's got to be must or must not. Absolutely mandatory. Has to be one of those two. But I totally assumed it was a must. It never occurred to me in any way whatsoever that it wouldn't be. And I think that that's probably what most implementers using this are going to assume.
Yeah, so to Mike's point, I think part of the problem we're having here is that the model that we're using for Connect here is somewhat different than the model that you might imagine for a classical HTTP proxy Connect, where there's a target that isn't really a target because there's no resource involved in any of the Connect stuff classically. Here we have a resource. We're making an HTTP request to a particular resource, and the effect of that request is to establish a web transport session to that resource. And so having a redirect here makes a great deal of sense because it does fit much more within the HTTP model of resources and redirects and all those sorts of other things. So I think that's why I lean toward the must here more than anything else. It doesn't make a lot of sense to have a redirect for a Connect. You're right, because there's that's bizarre. But Connect is weird in its native form, and this is what we're building here is much less weird. It's still a little bit weird, but it's much less weird. So I think must.
Jonathan Lennox, I agree, must or must not. And I also wanted to ask, you said there was weirdness that happened with WebSockets and redirects, and I'm curious if you could expand on that. So
I cannot. I would have to talk to people at W3C who.
Ah.
Yeah.
Okay, we've drained the queue. I'm hearing that a majority of the folks speaking want a must or must not. And I'm hearing preference towards must instead of must not. Is going with must something that everyone can live with?
I would prefer to continue discussion on the issue because I believe some of the people who might have objection are not in the room.
Oh. Yeah. So Victor said that he believes that some people who would object are not in the room, and he wants to continue discussion. So that makes sense. We don't have consensus here. We'll keep discussing on the list, and I'm going to give Victor an action item to get those folks to chime in, because I suppose you know who to contact there?
Yeah.
All right, thank you.
Next slide. Stream frame ordering. So there is so the way we do unidirectional streams is we define a stream type, which is just okay. The way we do unidirectional streams is we define a specific stream type. So there is a stream type, and then there is the web transport session ID, and then there is payload. For bidirectional streams, we do not have stream type, so we define a special frame that once you send that frame, the rest of the stream becomes just web transport data stream. And there is a question of whether we want to allow to send any frames on the stream before, and do we want to be consistent between unidirectional and bidirectional streams? If we are not consistent, then why? Do people have opinions? Because I know that people have expressed opinions on the issue.
So if you allow other stuff on one of these streams before you mark it as being part of a web transport session, someone's going to get confused. So there's always a possibility that you have code that essentially opens the bidirectional stream, looks for the session frame, and then switches. But it has a state machine that says when the first frame comes in, that will determine what I do for subsequent frames on the stream. That will determine the status of the stream. If you allow other frames on that stream, you mess with that logic pretty badly. Is there any reason you would want something on one of these streams that isn't web transport session?
As far as we can tell, there is no particularly compelling proposals
Right.
at this point.
Because if there was, say, a headers frame there, there's a very good chance that most servers will look at that and go, oh, that's a request, and then start treating it like one, at which point things will go poorly for everyone involved.
Yeah, so I guess the status quo is for unidirectional, it's already effectively forbidden because there's no provision into wireframing. And the question is, do we ban it for bidirectional requests? And so far, what I hear is suggestions that we should.
Yeah, I think we very much should ban it, unless we've got a very strong reason. Otherwise, it really would complicate the implementation at endpoints if we allowed for other stuff to appear.
All right, thank you.
Clarification question for you, Martin. Are you saying for all frames, including future extension frames, or do we punt that question for later?
I'm going to say everything. I think you want to have a disposition frame. So this basically establishes what the stream is, and will ultimately determine what extensions are available or not. Now, we may regret that, at which point we can revise the specification, but I'm fairly confident that when you have a disposition thing, that's definitive, and you want to have that first.
Okay,
and
thanks for
exclusively.
clarifying.
Yep.
Alan Frindell. So my first opinion is they should be the same, like whatever we do for bidirectional, we should do for unidirectional. I think the point that Martin was making about, well, if we did this, then people might assume that it's different or have buggy logic. I'm not sure I totally buy that. Like if the specification says that web transport is a series of frames followed by a frame which begins the unframed part, then people will write parsers that handle that. And if they don't, they're not following specifications. And I don't know, we can't make people follow specifications, I guess. But in terms of, I don't have a super compelling use case either, so I'm not going to lie down on the road here. But I think just the issue mentions either grease or potentially priority. I think the ability to have extensions in the future is easier if we say there's a series of frames followed by the beginning of unframed data. Otherwise, you would have to have a different way of, and you'd have a different kind of web transport session frame in the future to support that. So anyway, but I'm not super passionate.
Luke here, quick question. Do we have similar wording for the header frame? Because I think Martin brought up a point there that if a client assumes the header frame is first, but is that prohibited already, or is that just left up? Right, because we should probably just follow what HB3 does, and if it leaves it open, then we can leave it open.
Yeah, I see Mike coming in to answer the question.
Yeah, so it's a little more complicated than that. Because H3 does allow for the possibility of other frames to be introduced in the future. So what H3 does is when the spec says that a certain frame must be first, which, for example, the settings frame on the control stream, then that exact frame must be first with nothing else before it. But when we're talking about the ordering of headers and data on the request stream, it's all about sequence. The headers must come before you see any data. If you see data before headers, that's an error. But if you see something else before headers, that's potentially okay. And if you don't know what it is, toss it.
So I think the challenge that we're facing here is that HTTP3 assumes very strongly that the streams that it has, the bidirectional streams that are established, are for the purposes of requests. It doesn't really contemplate the possibility that they could be a different type of thing. And so when it doesn't say anything about the ordering, it does that under the assumption that it's already been determined that it's a request stream, and that's okay. And so if request stream is the default and the assumption that H3 makes, if we do anything other than force this to be the first thing on the stream, we're messing with that assumption, because an endpoint that's implementing this under the same assumption will look at things and see, oh, this is an arbitrary frame that I don't understand. this must be a request stream, because of course you can add new frame types that are extensions without any prior negotiation. So we're basically if we allow other things, then we're essentially punting it across to the H3 assumption. So I think we need the disposition to be upfront and unambiguous and very clear. Otherwise, we'll end up in that complicated place.
Did you want to say something? I just want to say that, I mean, there's a way to have what Martin is suggesting, and which is you have a frame up front, the first thing that says this is a web transport session, but it's a frame which does not start unframedness, and then you have potentially more frames, and then you have another frame which says, okay, but now we're starting the unframed part of the stream. So you could do it that way, but I think you could also, that was what it would look like if we punted this to some later version when we have a compelling use case. So I think that's probably what we should do.
Yeah, I think we don't. Yeah, I think the key point is we don't actually have a compelling use case for frames on web transport data streams. So, and I believe that if we require web transport session to be in front, that actually would simplify implementations, including the one in our code. So there are some practical advantages to that.
Do you want me to jump in, Victor? So I'm hearing from the room that folks want to do the same thing for unidirectional and bidirectional for consistency. And I'm hearing that folks are now leaning towards disallowing any frames but this one to start. Does anyone object to that resolution? Amazing. All right. I'll write that up in the issue. Thank you.
All right, next slide. This one is a more interesting. So there is this problem where we open a web transport data stream and we can reset it before the peer knows it's a web transport data stream and can associate it with it. So the problem is here is that once that happens is let's say we do that on the client, on the server, there is a stream that is half open, and it's now in a state where it's not clear what's supposed to happen to it because the client has reset it. And the issue is what happens to the other side of the stream. And I think my answer is this is not really a web transport issue per se, because that could happen to anything else in HTTP 3. So the question, I don't feel like we need to specify anything. I feel like implementations of HTTP 3 already have ways of dealing with that. I'm not sure if they're explicitly specified.
Mike Bishop. So H3 has an error that basically boils down to, I didn't see enough of your request to act on it. Go away. So, I mean, in this case, it's very similar.
If HTTP has provision for that, I feel like we don't even need to spell it out
Yeah.
because that's just
The stream terminated before a complete request was read, I believe is the way it's phrased.
Eric Kinnear, Apple. So this also could be solved by the thing that I think Alan was talking about. If we wanted to have an explicit message that goes on the control stream that says like, hey, you need to bill me for this one. This is essentially the same problem, right? You're saying, hey, I've got this stream, it's hanging out, and I don't even know if it was web transport. If it is, I don't know which web transport session it was. What the heck? Right. So that there is an opportunity to have a way to kind of catch up with that, to kind of have it resolve those lingering inconsistencies and leaks of things. It's not trivial, I think, to write text that's good for that, but it would solve this and the other problem. So maybe we're approaching the point where it's worth doing.
Yeah, I don't think it actually solves that because you cannot actually reference the stream numbers inside your reset.
All right.
MT, do you have a reason to jump the queue here?
Yeah. because Victor said something that's wrong.
Okay, go ahead.
So once you create the stream, you'll know what the stream identifier is, and so you can use it.
It's true, but remember, if you're translating H3 to H2, those are not consistent.
We're talking about H3 though. H3 has this problem. H2 doesn't.
Okay.
Alan Frendel. So I'm curious about what Mike said. It's sort of, if I'm a server and like only thing I receive is a reset stream and a stream number. First of all, I'm not sure everybody's quick API would even notify the application that that happened. I don't know. Maybe they would. Yeah, so I'm a little bit concerned if that's the only thing the server says, if it'll have a chance to send the like, oh, you sent me this stream and I don't know what it was. Also, what if that was a unidirectional stream? How would you even? Oh, this is only for bidirectional. Well, this is for both.
It has to be bidirectional.
This is the bidirectional case. Okay, so you have a way to send the answer there. Okay. Okay. Yeah. And so I think, I mean, I'll admit, so yeah, like I said, this is, we mentioned earlier, this is how QPAC does stuff, which is like, it puts the stream number on the other stream and it's like, hey, this thing got reset. So the accounting can be taken care of. It's a little bit not wonderful that it's an actual quick stream ID floating around in QPAC space, but that is, you know, we did it that way.
So and correct me if I'm wrong, Martin Seaman, since you filed the issue. Like, this doesn't sound specific to web transport for me. It's a bidirectional stream, so in H3 already, if the client opens a bidirectional stream and resets it, the server could, in theory, keep it open forever, but that would be silly. I'm pretty sure, I mean, I should check what our implementation does, but the correct thing to do is go, oh, whatever, kill this thing. Otherwise, that sounds like a resource exhaustion attack. And therefore, if this isn't specific to web transport, I don't think anything needs to be done in the web transport spec, and this can just be handled by H3.
So I think this is a web transport specific problem, because when the client creates the web transport stream, it creates it under the understanding that it's creating it within that particular session. Now, we're not doing, if we decide not to do any stream limiting and whatever else, we don't need to deal with that particular problem. But it does create on the server side a stream that the server can send on. And it needs to know what it needs to do with that thing it might want to send on it, because I don't know, maybe this is the protocol that you develop. You create a stream and reset your end and then expect the other end to do something with it. I don't know. So I think Eric's suggestion was perfectly good here. We can resolve the problem here. Whether or not we want to do the stream level accounting stuff, we can still solve it in that way. And it's probably still worth doing is to do exactly what Alan was suggesting, as we do with QPAC. Just say, oh, by the way, I reset this thing. Resets are fairly uncommon. We'll still need to send the resets because that's how Quick expects us to behave. But having a message saying, oh, by the way, this stream was created and reset, now you can connect it up with your session, is probably something that's worthwhile having, just so that everything runs neatly and everything can be accounted for properly.
Yeah, we have about 6 more minutes and 5 slides, so we might want to limit the queue from here on out, I think.
I agree. Thanks for putting that out, Bernard. All right, Alan, if you can make it quick.
Yeah, I'll be quick. I think what Martin said or someone just said reminded me that, like, what would happen if all we received is a reset and then the server was like sent you an HTTP error page, for example, onto a web transport stream on the other side. That might be very unexpected or do very weird things. So that's probably not what we want.
Okay, so I'm hearing a proposal of biting that bullet and having that capsule that makes the web transport session attached to a reset reliable. Does that does anyone object to that resolution? Sweet. Awesome.
Okay, so I think this is the last of the actual issues is we do not actually describe how we expect the web transport session to be closed. There have been a couple of proposals floating around. One of them is you send the closed capsule, you send the fin, and then at some point the peer responds with a fin. And other is like you send capsule, send fin, and send stop sending. Do people have preference between those two? I have a mild preference for one.
Which one do you prefer, Victor?
Prefer one.
I think you mean stop sending, by the way.
Oh, which one?
There's no stop waiting.
Oh, that's a typo. Yes. Either of those would require you to have a timer to eventually tear the entire thing down if the peer does not respond.
So Martin Siemens says off the mic, proposal to not need a timer. I don't think, why do you need a timer?
You need a timer. So I'm trying to remember. Oh, right. We definitely need a timer in case we will have only one session on connection, because if you only have one session on connection, you need tear downs at connection. That's why I have a timer. I suspect when you have multiple sessions, you can wait and you just lead to resource exhaustion if you never send a fin in response.
Alan Findell, I guess my question is, do web transport sessions not normally have a timer? Is there not a concept of an idle timeout? It's just completely open until the other side closes?
Yes, like, because we have no idea what the application wants. Maybe application wants to push notifications once every 5 minutes.
Okay.
Okay, so do you have a resolution you prefer that you want to propose to the working group, Victor?
I would just write in proposal 1 explicitly.
Proposal 1?
Unless people have strong reasons, unless people have to prefer reasons to prefer proposal 2 to proposal 1.
Let's do this. You go first.
And reminder to keep it short, we're almost out of time.
Can you explain why you prefer 1 over 2?
I believe that stops. There is a value in waiting for the server to acknowledge on the application level that it has received the capsule, and that is how it acknowledges, is by sending the fin in response.
What does the client do with that information, that acknowledgement?
If it's the only thing, it can immediately close the connection.
That sounds like an implementation issue on the client, or detail, right?
That's not really.
Yep. So I would like to point out that proposal 2 is closer to what we do in Quick. You send the connection close and you walk away.
Well, in Quick, you send the connection close. It's not that simple. Okay.
Yeah, so I think there's value to having the ability to do it either way here, in fact. So I think that there's value in sending a capsule saying why it is that the connection closed. And I think either side should be able to send that in this circumstance. So I think this is neither 1 nor 2. It is either side can simply send a capsule and a fin explaining what's going on independent of each other. Now, the question is how you respond to seeing that. And I think either 1 or 2 is an option here, because in the case where I want to walk away and I just say, I'm not going to pay any attention to what it is that you send from this point onwards. Stop sending is perfectly acceptable in that scenario. But you may be interested in knowing what the other side has to say as well, or at least you can't stop them from sending something with a capsule saying that they wanted to go away as well. So I think all of the possible options are available to anyone, and I don't see why we have to pick one.
I hear a proposal to maybe mention that both of these are possible, and like maybe just a sentence to clarify what the semantics are. I mean, they're pretty clear. If you're sending stop sending, it means you're no longer listening. How do you feel about that, Victor?
Sure.
Does anyone object to that resolution? All right. Phew.
Yeah.
And we are at time, so we're not going to be able to go through the last few PRs. Or if you want to
Yes,
say something specific about as well
very
as something.
specific thing is there are 3 PRs. Everyone please read them. I guess that's all I want to say.
All right, so let's wrap up. Thanks, everyone. We got a lot of stuff done.
Just to verify, I didn't hear any actions for me from this, right? I'm looking after this working group while Francesca's away.
Yep, you're all good. Thanks, Mary. So we got folks to be like, everyone seems okay with the output of the capsule design team. That's great. That was blocking quite a few other issues that we're going to be able to make progress on. We got a resolution, quite a few other issues on H3. And so that was very productive. We do have a few other issues that we haven't gone through in PRs that need to be reviewed. So please take some time to do that. The editors will spend some time, like we'll be discussing the capsule design team PRs on the list. Once those are merged, we'll have more discussions on the issues that were blocked on that resolution. And we'll see. Maybe we'll have an interim before London. Go ahead, Bernard.
Yeah, that was my question. I guess we'll bring it up on the list, David, right?
Yeah, let's, my gut feeling is let's get the output of the design team merged, assuming there's on-list consensus for that, and see if we can progress the other issues on GitHub. And if we feel like a face-to-face, probably virtual conversation would help, we'll organize an interim. So thanks everyone for coming, and see y'all soon on the list.
Thank you.